नहीं यहाँ पे होता है ना इसी के सेकंड कपिल मैं इसको सेट में करता हूँ। The session is it's an old session. पहले सारा सेटल डाउन करो। आई जस्ट कॉल देम इन 2 मिनट्स। हां ठीक है, यहाँ पे जगह है बैठने की और एमसी यूज देम। कैन यू आस्क हर? यस। 2 minutes, 2 minutes. After 2 minutes, after 2 minutes, please. After 2 minutes, please. और ये आप इतना उधर
Well, my sincere gratitude to you all August members for having waited with us. The esteemed panel is ready and they shall be joining us any moment here now. May we please have enough room at the entrance for the speakers for the session to walk in comfortably. We already have some of the eminent dignitaries and guest speakers for this session amidst us. We just await the other panel members to join in for us to unveil the formal proceedings for the session.
Yes, please. In fact, some of them are working in the ground. Because I think it's that would look better.
The magnificence of this venue and the erudition has probably made all the eminent speakers walk across auditoriums. And I assume we have them all now with us. Thank you so much for waiting and for being with us. And with your permission, may I please unveil the formal proceedings for the session? Sir. So, ladies and gentlemen, for building stronger, inclusive, and a holistic green hydrogen ecosystem, time now to power a sustainable future with the oil refineries and the city gas distribution. Well, ladies and gentlemen, we have with us an extremely applauded and a cerebral panel gracing this session. An exemplification of erudition, Mr. Tarun Kapoor, the advisor to the Honorable Prime Minister, Government of India. A seasoned IAS officer of the 1987 batch from the Himachal Pradesh cadre. Sir, this is his second stint in the PMO after his first appointment as the advisor to the Prime Minister's office in May 2022. A persona non parer, he handles economic matters and has got several significant positions in both state and central government, transcending to this current one. As Secretary in the Ministry of Petroleum and Natural Gas, Sir steered policies and initiatives related to the oil and gas sector. Sir, it is our absolute honor to have you amidst us. A very warm welcome to you, sir. We are privileged to have with us Mr. S.J. Haider, the Additional Chief Secretary, Government of Gujarat. Ladies and gentlemen, the keynote speaker for this session. A noted IAS officer of the 1991 batch, Sir is presently discharging duties as Additional Chief Secretary of Energy and Petrochemicals, Government of Gujarat. Since joining the Government of Gujarat, he has served across levels and positions in various departments like tourism, urban development, panchayat and rural development, education, science, technology, climate change, and many more, to his versatile, able aura and persona. A very warm welcome to you, sir. It's our honor to have you amidst us. Well, ladies and gentlemen, the session shall be moderated by Dr. S.S.V. Ramakumar, the Chief Technology Officer, Executive Vice President of AM Green, a company promoted by Greenco. Dr. Ramakumar has more than 3 decades of uninterrupted experience in downstream hydrocarbon sector. MNRE's National Expert Committee member with over 150 research publications to his name, countless patents, ladies and gentlemen, with coveted awards like the NPMP, FIPI, NRDC, IMA Innovation, Bangalore Nano, and the WPC Excellence Award for Product and Process Technologies he developed. A coveted and an honored receiver of many laurels. He is the Distinguished Alumni Award for the year 2021 in Technology and Innovations domain too. A very warm and hearty welcome to you, sir. The eminent panelists gracing this session are Mr. Rajesh Kumar Mediratta, MD and CEO, Indian Gas Exchange. A gold medalist mechanical engineer, sir brings with him 3 decades of experience in the power and gas sector. A key role in commencing first electricity and gas exchange in the country goes to his name. The key founder member of the team for establishing the first power exchange the country in 2007 and gas exchange in 2019. With several papers on gas, power markets, renewable markets, commercial mechanism, energy settlement systems, and the list goes on to his name. It is our privilege, our honor, an overwhelming moment for us to have such applauded personas amidst us. Warmly welcoming Mr. Lalwani, the Executive Director, Torrent Power. And this time, I wish to say, with almost half a century of voluminous experience that comes with him, he is a part of the top management as Executive Director with over 16 plus years and a part of governing body strategic decision-making, steering the organic and inorganic growth through M&A. Build your own, operate your own for diverse sectors, asset management, portfolio management, project execution, green hydrogen projects, pre-development of green ammonia projects. His expertise goes far beyond. A very warm welcome to you, sir. And now warmly welcoming Mr. Kapil Maheshwari. And may I please request you to join in to make this a welcome note by extending a round of applause. We are now welcoming another eminent panelist, Mr. Kapil Maheshwari, Chief Executive Officer, Welspun New Energies, presently leading green hydrogen development at New Energy initiatives of the Welspun Group. He is responsible for developing strategy and its implementation. He was earlier leading the Reliance New Energy for renewable energy and green hydrogen development. With more than 2 decades of professional experience in renewable energy and sustainability, he has experience of design and implementation of over 2,000 megawatt of solar farms and rooftop installations in US, Germany, and India. A very warm welcome, sir. And now join me specially in welcoming Mr. Alex Bauer, the Global Head Marketing and Sales Hydrogen from Gentari, who's there amidst us. A very warm welcome on these lands of India to you, sir. Bringing with him an exemplary experience of 20 years in the energy sector with roles in trading, marketing, business development, covering hydrogen, power, and LNG markets. His career spans and transcends across prestigious roles and organizations like Intercontinental Energy, Total Energies, academic hat, bright and colorful, with feathers of degrees from management, energy, trade, finance, and economics domain. A very warm and hearty welcome to you, sir. And now we're warmly welcoming Mr. Samir Saxena, the Vice President, Green Hydrogen at Renew. Mr. Samir Saxena, a chemical engineer and a business leader with a bountiful experience of over 28 years, is in the refining petrochemical green technologies domain, serving as Renew Vice President and Head of Engineering for the Green Hydrogen and Derivatives business. He is spearheading excellence at Engineers India Limited, Lumis Technologies, KBR Technology, and Technip Energies. With that, ladies and gentlemen, we invite the exalted and the erudite persona. And now to take the session forth, may we please have the honor to hear from you, sir, Mr. Tarun Kapoor, the esteemed chair for the session. Ladies and gentlemen, with a resonating round of applause, over to the esteemed session chair.
Good afternoon to all the panelists and all the participants. I would like to maybe just give a little bit introduction about what I think that what role green hydrogen can play in oil refineries. So this includes oil refineries and city gas distribution. So both areas are different. The requirement of both the areas is different. In refineries, hydrogen is used even now. So wherever hydrogen is already used and we want to replace the gray hydrogen with green hydrogen, the cost difference is still there, but maybe it's 2x. So if we assume that we will be able to produce green hydrogen at say $3 or $4, and already the hydrogen which is being produced at say 150 rupees, 160 rupees, or maybe around say $2. So we are talking of moving from say 1.5 to 2 or $2 to say $3 or $4. But where we want to compete with some other fuel, say we want to compete with say petrol, or we want to replace say electricity or some other fuel with hydrogen, there the cost difference may be much, much higher. The advantage with refineries is that one part, which is again a difficult part, is how to handle hydrogen. So that experience is already there. because hydrogen they are already handling, but they don't store too much hydrogen. They produce hydrogen in the refinery and they use it immediately. Whereas with green hydrogen, you may have challenges because if you want to produce green hydrogen next to the refinery, then you have to get renewable power from somewhere far. And if you want to get renewable power from somewhere far, then you need that kind of transmission. If you want to produce round the clock, then you need round the clock green power, which then makes it very expensive. So if you want round the clock renewable power, and the cost of renewable power, including transmission and maybe other charges, it may come to say 6 rupees or even higher. But if you can do an intermittent kind of green hydrogen production, maybe you can bring down the cost substantially, because then the cost of green power can come down. So if you do that, then you need storage, and you have to handle larger quantities of green hydrogen. So those are the kinds of challenges which may be there in refineries. Or the other alternative is to produce green hydrogen somewhere far off in bulk, in put up very large plants, because if you do a 1 million ton kind of a capacity, then probably with scale you can keep the cost low. So if you do that, then you can transport hydrogen, but then transportation, storage, those are challenges. So right now, which is a more difficult challenge and which is a easier challenge, that also people are not very sure of, because nothing is available on the ground to really understand how this will be. And on in city gas distribution, because in city gas distribution we are using basically natural gas, and which is methane. So we can do blending of natural gas with some amount of hydrogen, which has already been tried. So by volume, what has been tried here in Delhi was 18%, 18% by volume. So it worked quite well. It does reduce emissions drastically. It does have certain benefits, but it has some problems also, because hydrogen molecule is small, so your piping, your everything has to be different. But then some studies were done, and it was thought that maybe up to 2% or 3% by volume is easily possible in the current network. So those types of experiments are also going on, but nothing very major has so far happened. But then if we are mixing hydrogen with the natural gas, then again we are adding to the cost, because if we put in say even small percentage, and this costs say 3 times or 4 times this, not even 4 times, maybe even more costlier than natural gas. Green hydrogen does have a higher calorific value, so maybe twice. But when blending was done and the experiment was done in Delhi, then after blending, uh, they didn't see any noticeable increase in the calorific value of the blended product. But then probably some maybe some other changes may also be required to be able to get that benefit of a higher calorific value. So for that, then maybe the way it is used, there also some changes might be required. So these are some of the issues. I won't talk too much. Maybe the other panelists may be able to put more light on it. But all I want to say is that if we have to make green hydrogen a success, then both these areas are the first where green hydrogen can be introduced. So there are so many areas where green hydrogen can come in. It can be in fertilizer, it can be in shipping by using methanol or ammonia, or it could be in transport of say trucks or certain other things. But the two areas where it is immediately possible, I think fertilizer is one, and the other is refineries. So these two, immediately it is possible, and some experimentation in the city gas distribution also. So with this, my good wishes to all the panel members, and we can go on with the panel discussion.
Thank you very much, sir, for your pearls of wisdom. And may we now please request you, sir, Mr. S.J. Haider, the Additional Chief Secretary, Government of Gujarat, to kindly make his presentation.
Minute. Good afternoon, ladies and gentlemen. It's a matter of great honor for me to be here amongst all of you. It is indeed a matter of privilege, and I am thankful to the Ministry of New and Renewable Energy to have given me this opportunity to address all of you and talk about some very fascinating possibilities as we navigate through challenges and constraints. We are pretty much optimistic that at the end of the tunnel, so to say, it's all bright and wonderful. So here is a small presentation on green hydrogen, and obviously it's a cleaner option. There cannot be two views on that. And in terms of viability, of course, we will be facing some teething troubles, but sooner than later, the techno-commercial viability also would establish itself with the passage of time, the way it has in respect of solar energy, harnessing solar energy. I am reminded of the days in Gujarat initially when the purchase power agreement, it was like of the order of 15 to 16 rupees per unit. And now it has come down to something like 240 or 250. So as all of us know, the country as of now happens to be the fifth largest in terms of GDP. And by 27-28, we would be becoming the third largest in the world. And we would be crossing the $5 trillion mark. The GDP is progressing significantly. If we look at the source-wise energy supply of 2023, even as of now, coal, oil, gas, they happen to constitute the major components, whereas the upcoming renewables, hydro and nuclear, they constitute a sort of minuscule minority. But then we are pretty much optimistic that in the days to come, if you look at the installed capacity of renewables for the entire country, in fact, it has crossed 200 gigawatt. And the state of Gujarat has an installed capacity of something like 29 gigawatt. And if we look at green hydrogen, to begin with, we are reminded of the Panchamrit commitments enunciated by Honorable Prime Minister Shri Narendra Modi ji when he was there in COP26, November 2021, Glasgow. And Honorable PM made these 5 commitments before the international community. 500 gigawatt of non-fossil fuel, then 50% of energy requirements to be met out of renewables, achieving net zero by 2070, carbon emission reduction by 1 billion metric tons, and carbon emission intensity reduction by 45%. Green hydrogen, as we have come to see, is having all the potential to become an alternative for enabling this clean energy transition across multiple demand spheres. The demand as of now is of the order of 7 million metric tons per annum, which would be mostly going up to 12 by 2030. And most of the hydrogen being produced, as all of us know, as of now, is through fossil fuels. we have a look at feedback scenario and energy carrier scenario. As regards India's green hydrogen mission, we all know that we have got a target of 5 million metric tons per annum. But this morning, I learned that it has now been augmented to 7.5 million metric tons per annum. So that's quite heartening. That only goes to show that the level of preparedness of the entire country is very much up to the mark. And I would be happy to share that insofar as the state of Gujarat is concerned, we are targeting something like 3.5 million metric tons per annum by 2030. So the state of Gujarat alone. And towards that end, we have already earmarked something like 2.5 lakh hectares of land. But that is just the beginning, as Tarun Kapoor sir was also telling me, that there could be teething problems, there could be certain issues and constraints, which we are pretty sure we would tide with the passage of time. I talked about Panchamrit commitments and how exactly our Honorable Prime Minister Shri Narendra Modi ji put this self-imposed target before the world. And even today, this morning, we were very much honored to listen to the recorded message of Honorable Prime Minister. And Honorable Prime Minister was saying that even, I mean, the Paris Agreement and Paris Pact thing and whatever commitments we had made, we could fulfill those much in advance. The target of 2030 was there, but we could fulfill those years and years ahead of that. If we look at Gujarat's determination towards Panchamrit commitments, I am very happy to inform all of you that when Honorable Prime Minister was the Chief Minister of Gujarat way back in 2009 on 17th September, he founded an exclusive and dedicated climate change department to address the concerns of climate change through a slew of measures ranging from adaptation to mitigation. If we look at the scenario in Gujarat, as I mentioned, our installed capacity is close to 29 gigawatt, with solar power in terms of installed capacity exceeding 14 gigawatt and wind power exceeding 12. We have the highest wind power capacity, second highest solar power capacity, highest rooftop solar capacity, and we have 24/7 solar powered village Moderator. As regards green hydrogen pioneering efforts, we have allocated land and we have got good many policies about which I would mention very briefly in the subsequent slides. So, how exactly the state of Gujarat enjoys an advantageous position? So, we talked about ample RE power potential and strong transmission network. That's very, very important because merely putting in place installed capacity is not enough. And all of us know that the gestation period in setting up of solar and wind plants is less compared to the gestation period which you get to see in setting up of transmission infrastructure. So pari passu, it has to be commensurate. So that way we are very fortunate that we have got a very strong transmission network. Land and water availability, long coastline, 1,600 kilometers, and good port infrastructure, significant manufacturing footprint, and mature natural gas infrastructure, and significant policy support we have got a wonderful renewables energy policy of 2023. Land lease policy is already in place, under which we have granted significant chunks of land, parcels of land. Of course, they must be put to worthy use. Then we have Atmanirbhar Gujarat schemes for assistance to industries announced by the Industries Department. So in totality, there are incentives galore to persuade prospective investors to come forward in the field of green hydrogen, ammonia, and derivatives. I talked about the target of 3.5 million metric tons per annum, and there are certain other figures, and I talked about the policies also. I would not like to repeat them again, and of course, all these policies are available in the public domain also, and we have been, it's a matter of honor for us that the 4th edition of RE Invest would be organized at Mahatma Mandir in Gujarat from 16 to 18 September, just a few days from now. And I would also like to take this opportunity to invite all of you to be a part of that event, which is essentially organized by MNRE, and the host state happens to be Gujarat. Green hydrogen, a cleaner option for oil refineries. It is but obvious, and in oil refineries, like oil refineries and fertilizers, they would account for the use of hydrogen in a big way. And the use of hydrogen per se has not been a new thing insofar as refineries are concerned. Of course, it would have been gray hydrogen, and we would have to gradually move on to green hydrogen. So in hydrocracking, the use of hydrogen to break down heavy crude oil fraction into lighter valuable products like gasoline, jet fuel and all, desulfurization. Again, usage of hydrogen accounts for about 2 to 4% of total raw material costs in refining. And currently, we all know that it is gray hydrogen. So gradually, we will have to switch over to green hydrogen. And even though it has not been mandated, some of the PSUs are transitioning to green hydrogen usages in refinery. If we look at Gujarat's potential of green hydrogen demand in oil refinery, we have got 4 of them, and the total installed capacity would be something like more than 100 million metric tons, more than 10 crores out of 26 crore metric tons for the entire country. Again, this is another area where green hydrogen can be put to good use, and we can go a long way in decarbonizing the entire process. This is most economical mode of transportation through pipelines, emission-free mode of transport, safe, secure, and reliable, low infrastructure cost. A path for faster adoption of green hydrogen. We have got a ready set of natural gas consumers also, more than 1.3 crore domestic and over 64,000 industrial and commercial. The pipeline network available across the length and breadth of the country, and especially in talking about Gujarat. It's ready set up where green hydrogen molecules can replace fossil alkanes. We have like more than 3,500 kilometers of transmission pipeline, and it's spread over all the districts. We have Gujarat Gas covering some 21 districts out of 33, and then other players are covering other districts. If we look at the domestic connections and CNG stations and industrial and commercial establishments, these are the figures for the entire country, and juxtaposed with the figures for Gujarat. And in domestic connections, CNG stations and industrial and commercial establishments, Gujarat is respectively accounting for 25%, 14%, and 46% of the country's establishments. This is the GSPL transmission network in Gujarat. Pipeline in Gujarat is close to 2,800 kilometer, and GSPL has JV also with two transmission companies. Distribution pipelines for polyethylene and steel pipeline and CNG stations in Gujarat at a glance. Then green hydrogen blending in CGD network. This has already begun on a pilot basis at certain places in Gujarat, and it is yielding good results. So this is the pilot project I was talking about. Small number of consumers, but then it's working out well. Some of the challenges are like technical compatibility, cost impact, and impact changes required at the consumer side. Then certain bottlenecks, mapping demand, supply, and high production cost for green hydrogen, which of course, with the passage of time, I am pretty sure that it would come down. Now, way forward, of course, there cannot be any denying the fact that green hydrogen would definitely be cleaner, greener, and in due course of time, I would say a commercially viable proposition. And these are the areas in particular, refineries and fertilizers, even city gas distribution, and quite a few others would gain immensely, and we would be able to decarbonize these activities in a significant way, which would go on to help the country attain the revised nationally determined contributions which the country has put forward before the world. And it would go a long way in helping us realize the Panchamrit commitments of our Honorable Prime Minister. With these words, I must thank all of you for a patient hearing. Thank you.
Thank you very much, sir, for this exemplary and enlightening presentation. And now may I please hand over the session proceedings to you, the esteemed session moderator, Dr. SSV Ramakumar. Over to you, sir.
Thank you very much. Distinguished chairpersons, my fellow panelists on the dais, and delegates of second edition of this Green Hydrogen Conference. We have a very distinguished panel who would be addressing various issues and aspects of induction of green hydrogen into refineries and in city gas distribution. I would like to ask each of the panelists a few focused questions, which I discussed with them just before the start of the session. Let me make just one or two opening comments, especially pertaining to the refining sector. As Chairperson was mentioning in the beginning of this session, the refining segment, not only in India, but all over the globe, is the largest producer and largest consumer of hydrogen today. Percentage may keep varying, but in excess of 50% of the total hydrogen. And today, needless to say, everything is gray hydrogen, and the transition that we are talking today is from gray to green, nothing in between, no color. Now there is no uncertainty. Earlier, of course, we were debating whether it is directly green or via blue-green. I think that kind of debate was happening, but now I think more or less driven by the policy and driven by the clarity of thought, every one of us are working towards direct transitioning to green hydrogen. So collectively, at least the PSU oil refineries in this country, they have committed. I know I was a part of that till 2023 July. So 1 million metric ton till 2030 is the figure that is committed, which is slightly in excess of, rather in excess of 10% of the total hydrogen that is being used by the refining segment. And today, Honorable Minister of Petroleum in the inaugural session, he has mentioned that this figure might go upwards. The refineries may revise it upwards to even higher figures, higher quantum of this. So the cost dynamics is one thing, how much impact that this cost differential is going to have in the downstream product line that refineries are they are going to continue to produce. All those calculations are in place almost 5 years back when the national mission on green hydrogen roadmap was about to be set up. All the, at least the PSU oil refineries were asked to do a scenario planning of inducting from say 2%, as low as 2% to as high as 50%. What is the ramp up plan, and what kind of impact that it is going to have as far as the cost of the downstream product line that is going to be there. These scenarios are there, and these scenarios are there starting from $7 per kg to as low as $3. We didn't calculate for $1, though that is the aspirational target for the entire globe, that $1 per 1 kg in 1 decade, which seems to be difficult even today. US DOE also announced that they have revised their timeline for $1 green hydrogen to 2050, from 2030 to 2050. So I would only like to say that most of the refineries today are about to, at least the PSU oil refineries are about to, they are in the process of bidding for constructing their standalone captive green hydrogen production units, because that's the best way of inducting green hydrogen in refining segment. As again chairperson was mentioning, it is on, I mean, as it is produced, it will be consumed. There's no question of storage in refining segment. But if refineries have to realize and discover the real price of green hydrogen, they need to encourage the participation and competition of various players, because this sector is really unfolding and a lot of new consortia are in the making, and the typical financial pre-qualification criteria may put many players off the mark, and thereby the end loser is the consumer. So one consideration that the refining segment, especially the organized state-controlled refining segment, need to take cognizance of is to make a rationalized and universal bidding criteria, not to compromise the technical criteria of these bids. This is one comment that I would like to make coming from the same segment. And the second thing is the Indian green hydrogen definition is totally different from the rest of the geographies. You take Europe, you take US, barring China. China talks about low carbon hydrogen, it doesn't talk about green hydrogen at all. But it is only India which permits bio pathways for green hydrogen production. While it has stipulated 2 kg CO2 equivalent emissions per kg of green hydrogen as the capping emission limit, they have categorically mentioned, and we all were part of arriving at that definition. At least I am one of those persons who vouched for this, that the biogenic CO2 should not be considered under this 2 kg cap. So there is a specific purpose in doing so, because of the abundance of biomass availability here, at least in those refineries in whose vicinity the compressed biogas is available, and large SMR units, which otherwise is going to be redundant once you install the electrolyzer, you can use in place of fossilized natural gas, you replace it with CBG, and by invoking this definition, you can still produce green hydrogen. So this is one possibility. Most of the refiners are now taken cognizance of this, and wherever it is possible, people are thinking of using the same old SMR, very established SMR. No capex, no additional capex is required because SMR infrastructure is available in all refineries, and if CBG is available in good quantity in that particular vicinity of the refinery, instead of natural gas, you process the CBG to produce the green hydrogen. So these are some of the imperatives. Some pilot projects are already there. I know very well. I spearheaded one such project at Indian Oil R&D Center, where we could reform the CBG and could able to produce fuel cell grade hydrogen. I think I will stop here as of my opening remarks. Now I will move on to the first panelist, Mr. R.K. Mediratta from IGX. Sir, we would like to know from you how the green hydrogen trade is going to pan out in the days to come, and what kind of yes, sir. What kind of collaborations that you foresee to have a very practical green hydrogen trading
Thank you, sir.
like any other liquid products.
Thank you. Thanks a lot. First of all, MNRE for giving this opportunity to be part of this great event. And it was really enlightening to hear our chairperson, Mr. Kapoor, and Mr. Haider. Of course, they covered largely everything probably relating to refinery. Now, refinery and CGD. And see, we have been operating the markets for electricity and gas. We started since 2007. Gas we are doing since 2020. So what we have started doing for hydrogen is that we are trying to explore that how we can develop this market. Now, it's very normal to have trajectory of any sector, new upcoming sector for trading, building trading, developing trading in that sector is first you will have long-term contracts because you need to invest money in the project. So you need to have long-term tie-ups with the buyer, and then you develop this project. Slowly, projects develop across, and then it gains some kind of critical mass. And then after that, you start looking at the opportunities for short-term, because while you have developed a sufficient capacity and sufficient demand, then you think that there will be requirement for people to come under very short-term basis on a flexible basis, because sometimes somebody will be surplus, your buyer will not be interested in buying, and sometimes seller do not have any commodity, and that time buyer needs that commodity, and that time they need somebody else to supply. And for that, we need to really create market. And market does some more important things. One is that it discovers the price for the whole sector. So when you discover a price on the basis of transparency and competition, then that gives the price signal to the overall sector. And that's very important. Initially, when you have a long-term contract, there are tie-ups. Sometimes you don't know the price at which these tie-ups have happened because they are private contracts. And then you really don't know what is the right price for your commodity. And at that time you need to understand that what is the real price of a commodity for which buyer is interested to buy and seller is interested to sell. And that is given by the markets. So that's what we started exploring. And then we have some trajectory now envisaged. One is that, and that part we have seen elsewhere is also happening. One is that initially trades may not happen. So initially we need to create an index which will be based on benchmark prices. So we have capex coming in the projects, electrolyzer and other plant the machineries. then there will be OPEX for running the plant, and then there will be input, which is renewable energy. So if you know all the cost, you know that what is the benchmark price. So today, when we talk about $3.54, and that is the real, that is the price. But really, the technologies will keep on changing over the period. You will have different price for renewable energy. There will be different price for cost. So all of that we can integrate and actually create a index for the whole market, and that can give price signal initially, and later when we see there is enough capacities created, demand is there, and then short term trades have started happening, then we create a platform for doing the trade. And I'm very happy to announce, sir, actually what we have signed, we are going to have a agreement with the GIZ, who will be supporting us in developing a roadmap for green hydrogen market in India. And there we will also have a support from the largest European energy exchange, that is EEX. And we will be working together to develop this, to at least prepare a roadmap. And then based on the roadmap, whatever is required, we will do. And that is what we are working on. And the other thing, what we understand, that MNRE also has issued one draft for green hydrogen certificate. And that's also very relevant. Initially, of course, they are not also thinking of having this get a tradable certificate, because the quantity involved is in tons. But of course, as we go along, we will proceed to create more granular certificates, so that trading should be able to should happen. So another area which actually we should also look at, which probably we miss on the regulation side, because while Europe has done quite well in terms of looking at what is going to happen, how the network has to come. Initially, network will be blended network. Later, there will be dedicated hydrogen network. All of that, when they are talking, they also have come out with a hydrogen and decarbonized gas package, which is a regulatory package. And there they have given that how these networks should also be regulated. So they are saying that initially it will be negotiated network, third party access to the network. But by 2033, all these networks also will be regulated. So this is what Europe has done. Probably we should also start thinking, so that we are able to really create a well-functioning market when we are having sufficient capacities. And of course, sir, when we talked about the other MOUs or cooperative agreements, what we have signed, collaboration agreements, we have signed one with the ECME for developing this market, how we can grow this market. And second one, we have signed with GSPC. Haider sir, we have signed MOU with GSPC and GIFT. And then we will also be trying to develop Gujarat as hydrogen hub. What Haider sir already had said, it's so relevant that this has got all the things which are required to create a good hydrogen hub. And maybe when we set up a market, that can be the first one to start doing trade. And of course, when we will have markets, we will also need these hubs, and then these markets can develop around hubs initially. Then later, maybe we'll have a national market. So that's what we plan for. I'll stop
Thank
here.
you. Thank you very much. And it's very heartening that you are going to build a robust tradable roadmap for green hydrogen as well. That is definitely going to discover the price for hydrogen and help facilitate a faster induction of green hydrogen into the energy economy. Let me move on to Mr. Lalwani of Torrent Power. They have, though it's in a demo scale, they have right now executed an integrated green hydrogen and ammonia project. So it's worth listening to him about his experiences. What are his experiences and challenges in executing this project? Maybe, sir, you take 2 to 3 minutes in the interest of time and other panelists. Yeah.
So, good evening, everyone. So there are in Torrent, actually, I don't know, just for the sake of introduction, Torrent is the business of the pharmaceutical, then power, and then we have started the city gas distribution. There are 16 GA circles we have across India, different various states. And in Gorakhpur, we have started the first green hydrogen pilot project. And I will little bit, because this time we have not started as a pilot project. It is full-fledged, is a small project, but it should complete in all respect, so that when we decide about the scaling up, then we need not to do many changes in the design. So we have put a lot of efforts and spent a lot of time in designing. So it be almost like a full-fledged miniature project for the every CGD. So many challenges we have experienced. It is not just a blending of the green hydrogen with NG, but we have then realized, because you have a small plant in between, and either the gas supplier is supplied by the gas supplier, whoever is there, GAIL or whoever is there, GSPC is there, or on other side, the customers are there. So almost in the area where we are doing the pilot project in Gorakhpur, we have a 9,000 residential domestic users. We have almost like a 22 industries, 9 commercial buildings. So, and many of the CNG users are there. So both the PNG and CNG network is fully established in that one. To design that one, what changes or what are the challenges we face during the design? No, it is when you see that one, flow is not in your control, because demand is, you are not controlled. Demand is decided by the customers, whether it is industrial customer or the domestic customer. And it happens that when every night the demand goes to zero, almost zero, that for 3 hours there is no demand, either PNG or the CNG. And during the day also, as the day starts, people will start using the gas, then slowly the variation starts. So a lot of variation in the gas flow, as well as few hours when you have a zero gas flow. Now we have to design the plant considering, otherwise all the green hydrogen plants are designed, just blend the gas and finish and see the 2% I'm getting or not. But I have to see consistently, reliably throughout the year. I have to maintain desired concentration, whether it's 2% or 5%, that will decide. So in that case, I have to see that in this case, how I'll design the plant. If there is a variation in the normal standard design, normally the hot standby mode is not there. So we have incorporated hot standby mode, so that when you see an alkaline electrolyzer, you have to circulate the KOH solution. Now KOH solution, you send KOH, first of all, there is a possibility of precipitates will form and it will block if you don't do the proper at warm condition, don't keep the warm condition for whenever there is a minimum flow. So we have introduced again a circulation pump, small circulation pump and KOH heating, so that at least plant remains in a hot standby. So as and when the gas flow increases, we can start up ramping up the production. So this was not there in standard. We incorporate this one. Now, whenever we are getting the gas supply from the GAIL, and there is a variation in the gas supply pressure also. Now, how to take care of this one? I don't want to trip our plant. So we have introduced the buffer vessel in between and incorporate the control. Even the electrolyzers, we have asked that OEM what would be my ramp rate in the electrolyzer, because ramp rate and ramp down, it should be aligned with rectifier control as well as the electrolyzer OEM's design condition. So that is around 0.7% per second, that one the ramp rate and the ramp down is allowed. So that also we incorporated. And there is one more challenge you might have also, those who are in the green hydrogen business, you might have seen, there is a gas crossover through the diaphragm so gas crossover, normally it happened at the low turn down. Whenever you buy the electrolyzer, everybody says though this is designed for maybe 10%, or sometimes alkaline, the people take the turn down is 30%. But when you really operate the plant, when you design the plant, people will say, be careful and see that when you should not operate below the 14%, 40% turn down. So in that case, if something happens, if there is a gas crossover happens from cathode to anode, or in that case, what happens, the hydrogen will go there or oxygen will cross over on the cathode side. There is a possibility that one, because the explosive range is so huge, no, from 5% to almost like a 75, 78% of explosive, is a huge explosive range. if you don't take the proper precaution of monitoring oxygen, hydrogen and hydrogen in oxygen with a redundant transmitter. Otherwise, these will lead to an explosions. So all this we have considered how we can avoid that when transient conditions in the electrolyzer. So electrolyzer operates safely without any issue. So those we have, and other thing normally when you design that one, you don't consider that reliability of the. We have seen that one our electrolyzer should be fully reliable, and then wherever the redundancy of instruments, redundancy at the control level, we incorporate everything. So in that case, actually, we have seen when you design and ensuring that one now, if it took little bit longer time, 6 to 8 months to design the plant, but now it is only just after testing and commissioning, we have to scale up and do in the once the I think mandate comes, we can do it in other GS circles. So it was a learning actually, because once you have the intent that when you want to use this for the future and this one, then we put little bit more effort and see that on how we can design. As far as we have similar learning on the integrated green hydrogen and green ammonia plant, that also we have designed for that one. Actually, their learning, there are 3 segments in the green hydrogen, green ammonia plant. One is a renewable. Everybody knows quite matured. I need not to tell because we have come from the vanilla to FDRE and RTC. So RE is well matured. Haber-Bosch is also well matured. In between electrolyzer, alkaline electrolyzer technology is persisting for quite long. So that is also available. Now, only challenge when you design ammonia plant is actually integration of all these 3. When you renewable, because 60 to 70, 65% of the capital cost is because of the renewable only. So you have to optimize the renewable in such a way, and at the same time you have to optimize the electrolyzer capacity also. Because of the turndown, I am telling sometime there is a possibility you have to maybe club 2 technology, AC and the PEM electrolyzers are to be combined together, so that at least you have, and you have to little bit over design not only renewable but also the electrolyzers also. So these things, Haber-Bosch is fine, but in between you have to bring the storage. If you have a consistent ammonia plant, because I think turn down of ammonia is somewhere around 10%, all the license are guaranteeing. If the 10% is a turn down for the ammonia, then you have to see that whenever there is a radiation is down or whenever there is a cloudy weather, I'm not able to generate the renewable. I have to see that I have a minimum shutdown of the ammonia plant. So how I can minimize the shutdown? I have to increase the green hydrogen storage capacity between the electrolyzer and the Haber-Bosch process, so that at least during that period, I can run with a minimum shutdown of the ammonia plant during the year. And over and above, there is again, because transient also, we have to take care of the transient condition. For that, you have to introduce the batteries also, that one, because sometime, because ammonia plant is not like a switch off and switch on. You can switch off and it will, so you have to safely shut down it. Otherwise, the full of hydrogen can lead to the explosion. So you have to safely shut down. So over and above the renewable, you have to bring the storage also in between, and optimization of not only the hydrogen storage and the battery storage. You have to bring both together so that at least you take care of your design without any explosion or without any damage to the plant. So this is the 2 aspects actually we have learned about the 2 designs that I would wanted to share with you. Thank you very much. If anyone has a question, you can ask.
Thank you. I think we'll take up the questions at the end. Thanks for sharing the all the experiences and brass tacks of running an integrated plant, dealing with the fluctuations and things like that. Let me move on to Mr. Alex of Gentari. Mr. Alex, we would like to hear from you for our audience today. How your experiences of Petronas, decarbonization of Petronas in Malaysia as a country, you are going to induct in your Indian operations?
Yeah, good evening, everybody, and thanks for the question. So for those that don't know Gentari too well, Gentari is part of the Petronas Group, Petronas, the Malaysian integrated energy company. And Gentari is established about 2 years ago, 2 years to the day almost, to to basically look at the clean solutions for all across the energy spectrum. So today we're focused around mobility, also focused around RE, and also hydrogen. Those three business areas are what Gentari is currently active in, and all of those business lines are very active in India. So we clearly see the opportunities to invest and the prospects and for hydrogen growth in this market. So talking of India, so we're currently setting up a major, large-scale 2.5 gigawatt project for green hydrogen production. That's in the state of Tamil Nadu, and primarily that will be for export in the form of green ammonia. To the extent, of course, there is local consumption, local demand emerging from different sectors. I think refining is a very promising one. Then if you can consume hydrogen close to the point of production, then that is even more economical for all concerned. So the potential there is for longer term supply to domestic market as well. Just recently, Gentari, through partnership with Greenco in the AM Green, has just taken FID on projects in Kakinada. So for green ammonia production. So quite active in the space. And if we turn to the two topics or the two sectors which have been mentioned here today, so that's refining and city gas. I just have two reference cases which we are working on at the moment. Not today in India, but back in closer to the homeland of Malaysia and Singapore as well. So through the refining assets of Petronas, as well as the petrochemical business, we're currently establishing a green hydrogen project. That's a small one. Should produce around 10,000 tons per annum of green hydrogen. And that's at close to and will be connected to one of the refining companies of Petronas Group in the peninsula of Malaysia. Currently, that green hydrogen can either be serve two purposes. One can be straight into feedstock in the refinery and utilized directly as hydrogen in hydrogen form for hydrocracking and all the rest. Alternatively, there is ammonia production existing today. It's gray ammonia produced via SMR and NH Haber-Bosch. So we can potentially feed in green hydrogen into that process and have a blended product, which is, I would say, low carbon ammonia as the output from the existing production project. On the city gas side, so Singapore, for those that aren't aware, has a existing city gas network, which is largely hydrogen within the composition of the gas today that's used. Historically, that was a very high concentration of hydrogen due to the origin of the coal gas that was used. So the pipeline network that exists, which serves about 900,000 residential customers, also some industrial customers, is already using about a 30%, maybe 40% composition of hydrogen, grey hydrogen today. So we've formed a partnership with that city gas company, City Energy, to effectively replace part of that grey hydrogen with green hydrogen. The green hydrogen will be produced in the peninsula of Malaysia, in the southern state of Johor. Again, modest size of project, but we're talking of about 85 megawatts of renewable power and electrolyzer of similar capacity, about 80 megawatts. And that will be producing green hydrogen. And that green hydrogen we are looking to pipe across the Strait of Johor into the northern tip of Singapore. That will feed in straight into the city gas network, decarbonizing the existing footprint for City Energy. So this project should come on stream, all going well, in 2028. We're currently going through the advanced, more detailed engineering phases. So those are two sort of reference cases, which I think are quite relevant as well potentially for Indian market. Of course, when we're talking of maybe 85 megawatts of electrolyzer, that's minuscule in the big scheme of things in India. So we're quite hopeful that here the things can be scaled up, and on that basis of a return of experience through operating this in Malaysia and Singapore, that will be a good foothold to build upon in the Indian market.
Thank you very much. These are really worth emulating. Disregarding the size, they can always be, this experience can always be used for scaling up to the demand that is there in the Indian market. Thank you very much. I would now turn to Mr. Samir Saxena of Renew Power. It's seen that the current traction for green hydrogen has actually regenerated the renewable energy companies. In fact, they are into the forefront. I would like to ask Samir, how is it going to help a renewable energy player to transition to an integrated green hydrogen production company? What kind of expertise of Renew Power, renewable energy, Renew is your brand name, your company name, but renewable energy, what kind of these expertises, how they can help really operating or erecting very good green hydrogen production plants, thereby finally, achieving the economies of scale for green hydrogen production costs.
Sure. Right. Thank you very much. And a very pertinent question, Dr. Ramakumar, you asked about this. I will try to limit myself within the timeline you said to the best of my capability. Before I answer your question, I think the subject line is, the use of green hydrogen in the refineries. I see, the refineries and the fertilizer industry and the city gas distribution as the low hanging fruits, wherein, the application of green hydrogen replacing the gray makes, very economical sense, as well as, the easy to implement one. There are various reasons where we see that, the demand of green hydrogen or the gray hydrogen in the refineries is going to go up with the time for various reasons. One is like the increasing demand of the petroleum products, which will again call for, the more and more hydrogen. The second is, the country is requiring much cleaner fossil fuel for the road transport and the aviation, and which again demands more hydrogen, and increasing the demand for the green hydrogen as well. And third is, we have moved, in last few decades from coker configuration to, high pressure hydrocracking configuration, wherein the hydrogen demand is very, very high. So I see that these three factors will enhance the demand of hydrogen in the refineries, and probably, if we are talking about greening the refineries, I think it makes more sense, and it will be probably more easy, and the result will be visible much faster. So coming to your point, there's a green hydrogen and the derivatives. They are like sort of a lifeline for the coming generation. When we are talking about the decarbonization, we are talking about the net zero in coming decades. The use of green hydrogen and their derivatives, replacing the fossil-based fuels and the feedstocks, makes clear case. When our country is marching towards the achieving the net zero, I see that our country is having a very distinct advantage of having abundance of natural resources. And when I'm talking about the natural resources, I'm not talking about the coal or the minerals, but the few elements which are needed to make the planet green or the country green. And it is nothing else but the wind, water, land, and the sun. And fortunately, our country has all these four resources available in plenty in different parts of the country. And if these elements are used in a very proper way, in a right proposition, probably we can lead the industry can lead the globe in terms of implementation of the green hydrogen and greener fuels. Now there are many countries who are having very ambitious plan towards the decarbonization, but the fact remains that they are suffering from these four elements. They don't have the land, or maybe enough sun or the wind, and therefore their dependence is a lot on countries like us. And this is the situation, which is encouraging IPPs, to leverage their strength to come into this game and, contribute the best they can do. Now, I see that, the IPPs, they have a lot of strength on the power sector. They have a fantastic control because they have been in this industry for almost like decade, I would say. And probably the kind of experience they have, they can very well utilize to integrate the process plant and the RE facilities. Typically, when we set up a process plant, we look power as a supply. We go for some sort of contract and get the power supply. But in this particular case, if we have an integrated solution wherein your RE is integrated with the process plant, probably there are more chances of optimization. If you talk about the integrated plant, about 65 to 70% capex contribution comes from the renewable side. And if you really integrate and try to optimize, probably we can have the hydrogen costs relatively better as compared to when you think that there are two separate entities and two separate fields. Now, if I talk about Renew, we are very pioneer and one of the top RE players in the country. We have almost like 10 gigawatt of renewable assets currently in operation. 5 gigawatt of power, RE power is under implementation, and we expect that in next couple of months that will also be online. Apart from that, we have won some recent projects, and we are very strongly working towards that. The kind of experience we have from implementation of such large RE project, we have a very strong control, and I see and envisage that the other IPPs also have similar kind of experience and they can leverage it. We have a very strong team of engineers. We do complete EPC work, our own. We have OEMs, which is also owned by us. We have connect with the vendors, which we have developed in last decade. And all these we can establish and, channelize in such a way that our process plant, get the advantage of that. And the risk, and it's a sort of risk mitigation also, wherein you have full control on your renewables, which is a large part, and your process plant, which is a power guzzler. So in similar manner, I see that, other IPPs, they may find that there are, many opportunities to integrate these two and take the full advantage. So I just
Thank
conclude
you. I
there
think,
without taking much time.
you have really underscored the advantage of integrated assets of Renew Power and the hydrogen. Hydrogen would really offer you a great outlet, for immediate outlet for the Renew Energy. Thank you very much for that insight. So among our panelists, we have one core refiner in Mr. Rajmohan from Essar, and also he's non-state controlled refiner. So let's hear from him very briefly. What are your decarbonization initiatives? How obligated are you now that there are no state obligations on you for inducting the green hydrogen? But even then, how motivated are you to induct the green hydrogen into refining segment? And what are your plans? Whether your decarbonization plans also center around green hydrogen or not? Just be little more brief.
Yeah.
Though my question is not all that brief.
Thank you. Thank you very much. I think first I like to introduce myself because the anchor forgot to introduce me. And I am Rajmohan. I am representing SR business. And we are working on the lot of energy transition projects in UK and in India. In UK, we are operating one of the largest refinery. And I'm talking about the decarbonization activities and basically the energy transition activities. What we are doing in the in that refinery, that I think we can we can implement those schemes. What we are trying to follow in UK, in India. So that will be, beneficial for everyone. In fact, this we are setting up some blue hydrogen projects and as well as green hydrogen project in UK.
and some green hydrogen project along with some derivatives in India. That is our focus area in the energy transition. I like to touch upon mostly on this UK first, and I will come back to this in India later. As he touched upon the decarbonization, what we are currently we are in the range of around 2 million ton per annum of CO2 emission every year. And by 2030, we are trying to bring down to almost around 95% out of it, and only 5% emission will be there after 2030. And how we are planning to develop this, it is by all our means natural gas fired furnace in the refinery. We are converting it into the hydrogen fired furnace. And by actually we are implementing the blue hydrogen project. Basically, it is natural gas SMR plus carbon capture. And this UK government is providing a lot of infrastructure facilities in the hydrogen sector, like this hydrogen pipeline network and this carbon sequestration, and we are putting up some carbon capture to bring down that carbon emission from that. And so that, as I told you, that 2.1 million will be by putting some blue hydrogen projects, we are almost reducing around 50% of the carbon emission by using this hydrogen as a fuel. And second most important part is that we are setting up one of the world first hydrogen fired gas turbines, which will be currently now we are using the refinery of gas and the natural gas as a fuel for our this power projects, which is supplying power and steam to this refinery. And now we are converting this fully into this brand new hydrogen fired gas turbines, which will supply power and steam. So by this we will be doing almost around 0.5 million ton of CO2 we will be able to reduce that. And apart from that, there are a lot of energy efficiency projects like converting this steam fired into this steam driven into the
May I kindly be permitted to interrupt? If you may just allow us a minute, sir. Requesting you, sir, Mr. S.J. Haider, to kindly spare a minute more to us, as we'd like to present to you a token of our sincere gratitude for your gracious presence and pearls of wisdom amidst us. Doing the honors, we have Mr. Ravi Verma, member of the Governing Council of the Sustainable Projects Developers Association.
You can unmute the request. We were asking that these reports can also be just you do that. Or you can. I think there is a report to be unveiled before Mr. Haider sir is leaving, because he has to catch a flight. So sorry, Mr. Rajmohan, I think we'll do this and then we'll continue. So.
May I invite Mr. Lakshman to give a brief of this release, which is a report by NTPC?
I think don't take more than half a minute.
Thank you so much, sir. Good evening to all. And this report is about NTPC Green Hydrogen Blending Project, which we have set up at Surat, Gujarat. So what we did is we started our commission this project in 2nd Jan 2023 with 5% of hydrogen blending in the PNG network.
Okay.
Later, after 8 months of intensive exercise, we approached PNGRB and we got an approval for 8% of hydrogen blending. So from December 2023 onwards, we are blending 8% of hydrogen in the piped natural gas. So it was, and these reports give all such details of the project and what are the tests and evaluations which were performed. So complete information are provided in this report. And up to 8%, what is our outcome is that there is no degradation in the materials. There is a complete gas homogeneity between the hydrogen and the natural gas. And the main purpose of this particular project is not only a technical, a customer is also very important for this particular project. So we intensely trained all our customers and we continuously surveyed at periodic intervals and understand their concerns, and their actions has been taken into this particular project. And one more advantage of this particular report is that we added a standard technical specification and the scope of work for the green hydrogen blending project. Whoever wants to set up a green hydrogen blending project in India, So they can utilize this particular report where the detailed information is provided to set up the projects in India. So thank you so much for giving an opportunity to publish this report in this forum.
Thank you.
Another report lies there at the desk. This is a report by CEEW, and may I please request Mr. Karan to brief about it. This report is lying at the panel's desk. Thank you to the eminent dignitaries for doing the honors of the release. This was the release of the NTPC, and now we have the release of a report by CEEW.
Thank you. Good evening to everyone present. This report captures decentralized green hydrogen applications. It explores and profiles the potential green hydrogen demand out of them, the specific advantages that these decentralized green hydrogen systems can afford in these small scale industrial, commercial, and remote area applications, and offers a few policy recommendations to scale these systems and bring them from the margins to the mainstream. Thank you.
And if I may take another second here to just say, sir, you are a person of technology. I'm sorry, the human error surpasses and technology wins. The human error, because the agenda we got seems to be the obsolete one, that we could not have had welcomed you. Our sincere apologies that the agenda stands missing of the name of an eminent person like you. Ladies and gentlemen, this time it is especially from my side, but please join me in welcoming Mr. T. Rajmohan, the VP Technology for Essar Group. Our apologies and warmest of welcome, sir. Thank you. Please carry forward.
So Mr. Rajmohan can now continue.
Yeah, thank you. No, it's okay, ma'am. It is just to light the session. I just, made the point. Nothing else in mind. Okay. Yeah. Continuing that, as I told you that, coming back to that 2.1 million ton, we are, another 5 years time, it will be coming down to, it is almost 95% reduction. By doing all these, all these activities, which we can actually implement in, Indian refineries also. That's very much possible that, our ultimate aim is to, bring down the carbon emission in the refinery, which is the most significant in refineries, because almost considering the current, demand of around 3.6 million ton of hydrogen in every year in the refineries, and this is a good opportunity. So I think this is my point now. I think.
Yeah, so thank you and sorry for that interruption because the Mr. Secretary has to catch a flight. So now the last but not the least panelist of this session is Mr. Kapil Maheshwari from Welspun Group with vast knowledge of renewable energy and other initiatives. So I would like to indulge him in some kind of a crystal ball gazing. I would like to ask him the most astrological question that when green hydrogen in India is going to attain economies of scale and when we are going to achieve that wonder mark of $1 or $2 per kg. While I'm at the last, but you put me on the spot. So you have all the benefit of. So I won't go and possibly talk of indexing or renewable integration, cost perspective, etc. Coming straight to your question, and in interest of time, even I have to rush and catch a flight as well. Oh, nevertheless, see, I feel this phase of pilot projects which everybody is doing is around by 2027. So from now till 2027. But Government of India has put up the first PLI, and by which also 27 the plant should be up and running. So many of those plants have already been stages where
feasibility is done or feed is happening or FID is happening. We just heard from somebody on the FID coming in for that. And those are large scale plants. Those are not some of those small scale pilot scale plant. India is one of the country which has transitioned from gray to green directly. Very audacious, but wherever you go in the world, most countries on the supply side are talking blue, including some of the largest projects which are going through FID right now are speaking on blue hydrogen or blue ammonia. Um, as a country, we are possibly blessed with the lowest LCOE, and that makes sense rather than having a higher gas price, very unlike those countries where blue would make more sense at lower gas prices. We could look at green directly. So my guesstimates of the question what you've asked is possibly um, and possibly you have done with all the other panelists or compared to me. So this is a question which is coming as something which is what you have asked just now. But I feel it's post 2030 when we will actually see economies of scale coming in. I wouldn't call it as a time when we would see this $1 and $2 mark, but um, there are people who would be able to attain very near to that as an LCOH, if not at the price which it will be sold in the market. But an LCOH on the levelized basis, it could come near to those marks between 2030 and 35 is when economies of scale would be attained as well. The significant levers, I would say, to do that would be, of course, the price points at which we have renewable power right now, how we can make renewable power at those price points, which is round the clock. So if we have intermittent power anywhere available between 2 to 3 rupees, how can we make that at the same price with making it round the clock? So that's the largest lever, I would say. Some of the next levers which will come would be mostly from a perspective of electrolyzer. So it is improvement of efficiency, improvement of lifetime, improvement in the way it is maturing in efficiency technology. So you will get possibly the best of everything, the efficiency as good as SOEC and pricing as good as alkaline. And that's the wish list. By that time, it will come true.
Yeah.
You asked me to guess, so I am putting all my guesstimates.
Yeah, that is everybody's wish list. And I think I would add, even at the cost of interrupting you, that indigenous manufacturing is also one of the most significant levers, which is expected to bring down the price of electrolyzers.
Yes.
The first quote I remember 3 years back when I saw the first quote in Indian Oil, per kilowatt hour quote that I received for an alkaline electrolyzer, not even PEM, is $1,200.
Good.
$1,200. So today nobody is talking about that cost, even without an indigenous manufacturing unit coming up here. But think of what Mr. Alex was mentioning, that there is a 1 gigawatt electrolyzer manufacturing unit is almost on the ground by AM Green and Greenco. So I think many more projects are following. So definitely it is going to be one of the significant
Yeah, it is, and
cost efficient.
possibly the other aspect remains, and which is the central and state government incentives and policies which are
Yes.
already in place, and many of the states, while the center incentives are a little lesser in the tune, but many states are offering very attractive policies. Many of them have 30% capital subsidy on both renewable as well as on the process side of it. And the final thing which I feel which could help in attaining that would be the cost of financing. Like renewable, possibly it's a very norm that we have 75-25 or 80-20 as debt equity, whereas most of these projects are still have not gone there, and many multilaterals too. Indian banks would then see providing attractive financing. So the whole cost of capital will also then play a role when we move from pilots to large scale projects.
Thank you very much. On that positive note, 2030 used to look so far and distant, but we are just 6 years away, not even 6 years, 6 years away. So I think on that positive note, while we have concluded the interventions of all the panelists, but I think no panel discussion would be complete without taking at least one or two questions from the audience. So even at the cost of somebody getting delayed, let me allow some open house of strictly two questions, two compelling questions. Only two compelling questions. Okay, the person who first raised the hand, right at the corner, and next one. Okay, there are three. Let's see.
Yeah, I'm Banerjee from Hindustan Petroleum. Very, very enlightening discussions. Taking a cue from Dr. Ramakumar, he just now talked about a quote what he has received on electrolyzer. I always get intrigued by the propensity or the trend of green power manufacturer to shift towards green hydrogen production. One, is it a global trend that green power users manufacturing now they're trying to get into production of green hydrogen? What is the reason when everything is uncertain? One example you give just now.
I guess that Mr. Saxena from Renew Power has amply explained to you why all the renewable energy power companies are now resorting to green.
Certain thoughts because I thought I'll the best panel
Maybe offline you can discuss.
Two points I had. One is uncertainty as regards your technology is concerned. You mentioned about sure. Technology is developing, basis which there is a reluctance in signing PPAs by the consumers because cost is going to go down in the coming years. That uncertainty is prevailing. Distribution infrastructure is a challenge. There's a issue there. Regulatory risk is a challenge, but still the green power producers are getting into this space. So is it a trend globally or is it happening in India only? What is the reason like?
Would you like
I thought normal OMCs, cement, who are related to electrolyzer, they will get into production, not green power producers.
No, I think it is pretty much specific to India as of now, what I see, because if you talk about Europe, there is not much of renewable power available, right? Because of various constraints you all know. Similar situation is in the APEC region also, Japan, Korea, they all are constrained by space. They can't put a lot of RE there. So what I'm seeing, it is very specific to India, wherein, IPP, they have been very, very successful. There have been a exponential growth in the demand and they were able to meet it and very aggressive on this side. So this they seize as an opportunity to get into this business and take the benefit of it.
Okay, I think you can continue your discussion with him offline. Okay, I'll take the last question from him. Of course, 1 minute. He raised the hand first. Be little louder because for the others. No, it's fine. I think you are audible. It's a smaller room.
Yeah, as NTPC showed that 8% is mixed with the city gas. So if in the future, when we are increasing more amount of hydrogen to be added into the pipeline, is that hydrogen embrittlement will be happening and how we are going to mitigate it?
I'll answer that question. I'll answer that question because we addressed this in Indian Oil to some extent. See, already there are reports available in UK. The studies have revealed that the existing infrastructure of pipeline, if it is of certain quality of metallurgy, made of metallurgy, as good as 20% is good enough to get injected and get transported without any embrittlement phenomena. And now any new pipeline that is being laid down elsewhere in the other geographies as much as in India also, especially in city gas distribution, they all have taken cognizance of this fact that they would like to choose such a metallurgy which can beat this embrittlement phenomena. I mean, that is the dream actually, complete hydrogen transportation. But there are definite reports available, field trial reports available up to 20%. I have read one myself. It's a UK based report without any problem. Yeah, last question. Because of your persistence.
Thank you very much, sir. Genuinely on the city gas distribution side, World Bank has just started their study of the 33,000 kilometer line of India. We will have the reports very soon. But with all your panelists and other experiences, can you help me? What is the price that I could sell my gas or the green hydrogen that I produce today to a CNG or city gas distribution network? Or what are the buy price that they're doing at today?
No, I think it is very difficult at this stage to spell out any price on that. We are also waiting that what would be that. Lot of calculations are there. If any of the panelists would like to respond, want to take a guess?
They are the best ones.
Torrent may because they are very CGD players as well, and Essar, Torrent.
No, it's but upon a lot of factors, it's not only that, it is only that 2% blending or 3% blending is not only the factor which will decide the cost of your gas, final gas, right? Apart from that, there are other commercial aspects are also looking, we have to look into that. So it is, offline, I think we can discuss something on this, but it is to give any single number, it's not possible.
Okay, thank you very much. I think on that note, let me thank all the panelists for their very insightful interventions and sharing of experiences. I'm sure the participants must have been benefited by these insights. Back to organizers. Thank you very much.
Our gratitude abound to the learned panel for steering such an epoch-making session of deliberations, and requesting now Mr. Ravi Verma, Member Governing Council, Sustainable Projects Developers Association, to kindly do the honors of felicitating the esteemed session moderator, Dr. SSV Ramakumar. Ladies and gentlemen.
Thank you very much, sir.
Felicitations now to the eminent panelists, Mr. Rajesh Mediratta, Mr. L.N. Lalwani. Felicitations to you, sir. Thank you for your gracious presence here.
Thank you.
Felicitations to Mr. Kapil Maheshwari.
Thank you.
Felicitations to Mr. Alex Bauer. May we please have you for a moment, sir? Thank you for your gracious presence.
Thank you for
Felicitations to Mr. Samir Saxena. And felicitations to Mr. T. Rajmohan.
अब आप नहीं भूले इनको.
Thank you.
We can have one group photo.
A group photograph as we conclude this session.
Thanks.
And to all the esteemed delegate members who are still here in this room, may I take this moment now to extend our sincere thanks to you for your gracious presence, active participation, and patience to stay with us until this hour. Thank you very much. The journey to a greener, cleaner, and sustainable tomorrow continues over the next 2 days. Looking forward to welcome you again. Thank you.
Right, sir. Yeah. Pleasure meeting. Nice to see you again.
Hi, how are you?